So let's take a look at number 23. Number 23, I assigned as homework. But this is going to be metathesis, calcium chloride and potassium chloride solutions, a reactive form of precipitate. So calcium chloride, what's the formula? CaCl2 plus potassium chloride, formula? And so what are the ions? We're dealing with calcium ions, chloride ions, potassium ions, and fluoride ions. And so we're looking for good combinations. And the easiest way to figure out this is just switch the anions. If we switch the anions, then we're going to get calcium ions with fluoride ions. Calcium and fluoride is going to form CaF2. And potassium ions with, yeah, so it's just KCl. And they're saying in precipitate forms. So is the precipitate KCl? Could it be KCl? Group 1 salts are all soluble. So this is going to be aqueous. These are aqueous as well. And so the precipitate must be calcium chloride. This has got to be the precipitate here. And so all we need is the driving force. One driving force. This is the driving force, which we could say is precipitation. Driving force. Here it says, in the homework it says, it is not necessary for you to identify the precipitates. But that's too easy. And so you should be able to identify the precipitate for these. 24. Aqueous solutions of cobalt-3 iodide and lead-2 nitrate are combined. So let's do number 24. Cobalt-3 iodide, what's the formula? Is it soluble or insoluble? It's soluble because they say aqueous solution, so it's got to be soluble. It's got to be AQ. But we also know that chlorides, iodides, and bromides are all soluble except for silver, lead, and mercury. So this is not one of the exceptions, so it should be soluble. Okay, and then the other one is lead-2 nitrate. What's the formula for PbNO3? 2. Good. That's good. And then what we're going to do is we're just going to switch these. Sorry. I have to turn this one. But when we switch these, what do we form? So now we're going to have the cobalt with the nitrate. So it's going to be cobalt. How many nitrates are we going to need to balance out the charge on cobalt? 3. And so this is going to be CONO3 3 plus PbI2. Now this is something that I didn't do back here. I didn't balance this, which we have to think about. And I don't worry about balancing. When I'm figuring out what the products are, I don't care. You know, here I have 2 iodides, but I started with 3. Over here I have 2 nitrates, and now all of a sudden I have 3. And so I came up with an extra nitrate, and I lost an iodide. But I don't care about that because we can always balance it in the end. The same thing over here. I only had 1 fluoride. How did I end up with 2? Well, I end up with 2 by just putting a 2 in front here. And then I have 2. And then here I have 2 chlorides. I need 2 KCl, so it's balanced. So I balance it by the ions. And the same thing here. How can I balance this? Well, first I want to see if there's a driving force. If there's no driving force, then I don't even want to bother balancing it because nothing should happen. If there's no driving force, we get what's called NR, or no reaction. And so here I need to know, nitrate salts are all soluble. And so this is going to be aqueous. And then iodides are all soluble except for silver, lead, and mercury. So this is insoluble. So the driving force here is precipitation. Well, all I need is 1 driving force. If I have 1 driving force, then I might as well balance it. And so this is the way I balance it. Start off with the cobalt. So I have 1 cobalt, 1 cobalt. It's balanced. Then I have 3 iodides. Over here I have 2 iodides. It's not balanced. And so I have to balance it. Well, there are two ways of balancing it. If I have 3 iodides here, the easiest way of balancing this is multiply this by 3 halves. If I multiply this by 3 halves, the 2 cancels and leaves me with 3 iodides. And so I have 3 iodides here. Now I have 3 iodides here. But then I go, wait a minute, what about my lead? I have one lead here and I have 1.5 leads here. So how should I balance it? I'm going to do 3 halves here. Like that. Now I have 3 halves lead, and that gives me how many nitrates? 3 nitrates, 3 nitrates. Now it's balanced. Okay, we can leave it in fraction form, or we can get rid of the fraction. The easiest way to get rid of the fraction is to multiply it by 2. And so if I multiply it by 2, I'm going to get 2 CO3 aqueous plus 3 PbNO3, 2 aqueous, nitrates are all soluble, yields CONO3, actually 2 CONO3, 3, this is aqueous, plus 3 PbI2 solids.
Are you multiplying everything by 2?
Everything by 2.
Okay.
I have to multiply everything by 2. That'll get rid of the fraction.
Oh.
And so now I have 2 cobalts, 2 cobalts, 6 iodides, 3 times 2 is 6 iodides, 3 leads, 3 leads, 6 nitrates, 2 times 3 is 6 nitrates. So it's balanced. And we're good. All right, 25. Milk of magnesia is the precipitate that results when sodium hydroxide and magnesium bromide solutions are combined. Well, when you have your test, I'm not going to tell you what forms. You have to figure out what forms, because that's the purpose of predicting. And so this is a mix of experimental and predictive. And so here, milk of magnesia is the precipitate that forms. Okay, so we'll take sodium hydroxide. What's the formula for sodium hydroxide? NaOH. And magnesium bromide. What's the formula?
Br2.
Br2. Okay, good. Okay, then we'll just switch it. So now we'll have sodium ions and bromide ions. Sodium and bromide is just NaBr. I don't care about balancing, like I said before. And then we have magnesium ions with hydroxide ions. And so magnesium with hydroxide, I care about getting the right formula though. Is this the correct formula for magnesium hydroxide? MgOH2. Okay, all sodium salts are soluble. Hydroxides are all insoluble except group 1, ammonium, calcium, strontium, barium. And so that means this is insoluble, that's going to be a precipitate. And so this is the milk of magnesia precipitate. Okay, so now I have driving force. The driving force is precipitation. Here. Okay, now I want to balance it. So I have 1 sodium, 1 sodium, 1 magnesium, 1 magnesium, 2 bromines. 2 bromines, which means I need to multiply this by 2 to get 2 bromines, or bromides in this case. And then, is it balanced?
No, we need 2 NA.
Oh, now I need 2 NAs. It's the hydroxide. So now it's balanced. So we're good. Okay, 26. A precipitate forms when aqueous solutions of chromium-3 nitrate and sodium hydroxide are combined. Well, okay. Well, chromium-3 nitrate, what's the formula for that? CrNO3. Two? 3? Yeah. This is chromium plus 3. Each nitrate's a -1, so we'll need 3 of them to balance it. That's good. And then sodium hydroxide? NaOH. And so what are we going to form? We're going to form chromium 3 plus with hydroxide. CrOH3, good. Plus sodium with nitrate. NaNO3. Okay. Now let's see if there's a driving force for this. This is aqueous. This is aqueous. Hydroxides are all insoluble except for group 1, ammonium, calcium, strontium, barium. So this is not one of the exceptions, so that's a precipitate. And then all sodium salts are soluble. And so we have a driving force here. Driving force is precipitation of chromium-3 hydroxide. So we precipitate out the chromium-3 hydroxide, which is green precipitate. And we should balance this next. So when we balance it, I have one chromium, one chromium. One sodium, good. 3 nitrates here, but only 1 nitrate here, so I'm gonna multiply that by 3.
Then 3 sodium.
And then 3 sodium hydroxides, and then it's balanced. So this is good. 27, sulfuric acid reacts with barium hydroxide solutions. Let's take a look. I'm sorry? This one? This one is balanced here. All right, sulfuric acid, what's the formula? H2 SO4. H2SO4 is correct, sulfuric acid. Reacts with barium hydroxide. Now, what's the formula for barium hydroxide? BaOH2. Do you know all these say solutions? When they say solutions, that means it's aqueous. And so it makes sense, sulfuric acid should be aqueous. Hydroxides are typically solids, but this must be an exception. So hydroxides are insoluble except for group 1 ammonium, calcium, strontium, barium. So this is the exception, barium hydroxide. This is going to form what? So it's going to be H plus with the OH minus. What does H plus and OH minus form? Water. So H plus and OH minus, this is going to form H2O. And then we're going to have barium with sulfate. Barium's 2 plus, sulfate's 2 minus, so BaSO4. Okay. No, just BaSO4 because barium is 2 plus and sulfate is 2 minus. Good. And so these are going to combine to form this. Now sulfates are mostly soluble. And so I think the sulfate should be soluble except for silver, lead, mercury, calcium, strontium, and barium. And so this is one of the exceptions. So this is going to be a solid precipitate. So we have driving force here. The driving force is precipitation, EPTION. And therefore we should balance this. When we balance it, let's see what we got here. This is a little bit tricky, but we'll take a look. I have 1 sulfate, 1 sulfate. I have 2 hydrogens here. I have 2 hydrogens here, so it looks balanced, right? Then I have 1 barium, 1 barium. But then I have these 2 hydroxides. And so to balance out the water is like this. It's an H plus and an OH minus. That's what made the water. And so each water we can think of as having 1 H plus and 1 OH minus. So really, I didn't have the 2 H pluses here. This is H plus. I need the H plus and the OH minus. So to balance this out, I need 2. If I have 2 waters, that will give me 2 H pluses, and 2 waters will give me 2 OH minuses in terms of balancing ions. So this would be balanced here. Let's go on to the next one. 28. A reaction occurs when aqueous solutions of perchloric acid and sodium hydroxide are combined. The reaction occurs when we take perchloric acid. Okay, what is the formula for perchloric acid? HClO4. And sodium hydroxide, this is the NaOH. Okay, what does this form? Water and NaClO4, sodium perchlorate, it's called. And so this is aqueous, this is aqueous, water is a liquid. And what about sodium perchlorate? Will that precipitate out?
No.
No. This is aqueous. Sodium salts are all soluble. Well, if it's all soluble, then we have to look for other driving forces. What are the other driving forces we look for?
Strong acid to weak acid.
Okay, stronger acid to weaker. It doesn't have to be strong. So here's our acid here, perchloric acid. What's our weaker acid? So if we take a look at the weaker acid, you might think it's that, but it's not. So perchlorate is at the top. And then we'll go down the list. Do you see it? Here. Water. Water is our weaker acid. And so we're going from stronger acid to weaker acid, SA to WA. This is our driving force. We don't have any gas formation in this particular reaction. And since we have driving force, we should balance this. Is it balanced? It turns out, yeah, this is balanced. Yeah. One hydrogen, because we think of water as HOH. So one hydroxide, one sodium, one perchlorate, one perchlorate. So it's balanced. Sodium hydroxide is added to phosphoric acid. Let's try that one today. So sodium hydroxide is added to phosphoric acid. Sodium hydroxide, we saw that before, NaOH. What's phosphoric acid? H. H2PO4? Is that what? No, it's going to be H3PO4. Phosphates of 3 minus. We're going to need 3 H's to balance it out. And so what should form here? Water and sodium with phosphate. And so sodium with phosphate is going to form, well, phosphate's a 3 minus, sodium's a 1 plus, so how do we balance that? Na3PO4. So this is sodium phosphate and water, H2O. Water we can think of as HOH. So that's probably balanced. H3PO4 will need 3 waters, 3 HOHs. That's going to give me 3 sodium hydroxide. And so is there a driving force for this?
Stronger acid to weaker acid.
Yeah, what's a stronger acid?
Hydrogen and phosphate.
Yeah, or phosphoric acid. It's stronger. It's not a strong acid, it's just a stronger acid, and this is a weaker acid. And so it's all relative. And so there's a driving force for this. We're okay. Number 30. Let's see. Let's take a look at their answers here. Looking at their answers. That's what we got. Number 30. A reaction occurs when aqueous solutions of hydrosulfuric acid and sodium hydroxide are combined. Hydrosulfuric acid, what's that?
H2SO4.
H2SO4, wasn't that just sulfuric acid?
Oh, sorry.
Yeah. Hydrosulfuric acid. Hydrosulfuric, does it have oxygen or no oxygen? Hydrosulfuric means the anion is, hydrosulfuric means the anion is sulfide. If the anion is sulfide, then it's H2S. There's no oxygen. Only sulfuric and sulfurous will have oxygen. Hydrosulfuric, there's no oxygen. So hydrosulfuric acid and sodium hydroxide. What should this form?
Water.
Water and?
Sodium sulfide.
Yeah, so water and sodium sulfide. So let's write water here, sodium sulfide. And so we need 2 sodiums. Throw that there. That means we're going to need two waters. That'll balance it out. Is there a driving force for this liquid? Sodium salts are all soluble. And these were solutions, so this is aqueous, this is aqueous. So let's take a look. Is there a driving force?
Yeah.
All right, do you see hydrosulfuric acid?
Yeah.
Hydrosulfuric acid is here
To water.
for water. So we have stronger acid, hydrosulfuric acid, to weaker acid, water. So SA, WA, and this is what we call a driving force here. Stronger acid, weaker acid. All right, this is unclassified. They made the pass action easier because all those were metathesis reactions, but not all these are metathesis reactions. So we have to be able to recognize when we're dealing with metathesis and when we're not. And so if we look at 31, lead-2 nitrate reacts with sodium iodide. Does this sound like metathesis? Yeah, because lead-2 nitrate, ions, lead-2 ions, nitrate ions. Sodium iodide, yes, ions, sodium ions and iodide ions. So it's all ions, therefore we expect it to be metathesis. Metathesis has a form, which we call AB. This is AB plus CD yields AD plus CB. This form is called double replacement. Double replacement. So if it's AB plus CD, then we expect it to be double replacement, which is a metathesis reaction. And so let's go. Lead-2 nitrate. What's the formula? PB NO3 2. This is my AB plus CD, which is sodium iodide. Na. This is my CD. Let's go with AD. It would be lead-2 iodide. What's the formula for lead-2 iodide?
PbI2.
Okay. Iodides are all soluble except for silver, lead, and mercury. So this is an exception. So it's going to precipitate. Plus sodium with nitrate. Okay. So we have driving force here. The driving force is precipitation. Now I'm going to do something. If it's aqueous, I'm going to omit AQ. I'm not going to write it down because it takes too much time. And so if there's nothing written, it's aqueous. If there's something written, it'll be solid, liquid, or gas. In this case, it's solid. So we got driving force. So let's balance it. How should I balance it? I need
2 NO3s.
2 NO3s, so I'll need 2 the B's and
2 sodium.
2 sodiums, and then 2 iodides. And that's balanced. Good. Okay, that's 31. Let's take a look at 32. A precipitate forms when aqueous solutions of calcium nitrate and potassium carbonate are combined. Does that sound like metathesis to you? Number 32. A precipitate form of calcium nitrate, ions, potassium carbonate, ions. So this is metathesis. Here. So let's take a look at this. Calcium carbonate or calcium nitrate. Calcium nitrate, what's the formula? CaNO3 2 plus potassium carbonate. What's the formula for potassium carbonate? KCO3. It's going to be K2. You know, potassium's a plus, carbonate's a 2 minus. So these have to combine. It's going to be K2CO3. So what forms here? Is it a double replacement or metathesis reaction? What's going to form is calcium with carbonate. So calcium carbonate, which is Ca. Calcium carbonate, is that soluble or insoluble? Carbonates are insoluble except for group 1 and ammonium. This is not one of the exceptions, so it's precipitate. And then potassium with nitrate. So potassium nitrate is just KNO3. And so we have driving force here. Driving force is precipitation. And so therefore we should balance this. If we balance it, what do we need? 2 potassium nitrates. So, all right, let's look at number 33. Number 33, the fuel butane C4H current 10 burns in oxygen, forming carbon dioxide and water. Does that sound like metathesis to you? No, it's not metathesis. 34, acetaldehyde, a raw material used in the manufacture of vinegar, perfumes, dyes, plastics, and other organic materials such as oxides, reacting with oxygen, forming carbon dioxide and water. Does that sound like metathesis?
Yeah.
No.
Oh.
It's not ions. Acetaldehyde sounds like it, but it's not. 35, sulfurous acid decomposes spontaneously to form sulfur dioxide and water. Does that sound metathesis to you?
Yeah.
Sulfurous acid, yes. But sulfur dioxide and water?
Oh, it's not double replacement.
Yeah, it's not the double. This is one of them. This is a potential product. Sulfurous acid is H2SO3. That decomposes spontaneously to H2O liquid plus sulfur dioxide gas. But this in itself is not a favorable ion combination. This is just having this unstable compound that decomposes.
So metathesis is only double replacement?
No, metathesis is ion combination.
Okay.
Ion combination. Carbonate beverages contain carbonic acid, an unstable compound that decomposes in carbon dioxide and water. This is not metathesis in itself. It's just carbonic acid decomposes into water and CO2. The metathesis part comes how we form carbonic acid. Carbonic acid is formed by the hydrogen ions combining with the carbonate ions. So this would be metathesis, but this part is not metathesis.
What's a metathesis? Can you show us an example of a metathesis problem that is also decomposition?
Thursday we did. Thursday we did one. I'll show you another one.
Okay.
Calcium reacts with water. That's not metathesis. Calcium is an element. Bubbles form when metallic barium is placed in water. That's not metathesis either. Zinc metal. No, we're not dealing with ions. Chlorine gas, not ions. 41, this is metathesis. Ammonium sulfide is added to a solution of copper 2 nitrate. This is metathesis. 42, silver nitrate is added to a solution of sodium sulfide. That's metathesis. 43, phosphorus tribromide is produced when phosphorus reacts with bromine. That's not metathesis. There's elements there. 44, when iron reacts with oxygen, iron 3 oxide is formed. Is that metathesis? No. When calcium hydroxide, sometimes called slake lime, is heated, it forms calcium oxide, lime, and water vapor. Does that sound like metathesis? No. Hydrogen peroxide decomposes. Is that metathesis? No. Glycerin is used. And so when we look at this, non-metathesis, however, 51, a solution of potassium hydroxide reacts with a solution of zinc chloride. Does that sound like metathesis? Yes. 52, a precipitate forms when aqueous solutions of silver nitrate and magnesium sulfate are combined. Does that sound like metathesis?
Yes.
Yeah. Solid ammonium dichromate decomposes, not metathesis. Magnesium nitride is formed from its elements, not metathesis. A solution of lithium sulfide is mixed with a solution of sodium phosphate. Yes, metathesis. Sulfuric acid and zinc hydroxide. Yes, metathesis. Chromium nitrate, chromium 3 nitrate is mixed. Oh no, this is metallic chromium. Metallic chromium, is that an ion?
No.
No, not metathesis. Lithium is added to a solution of manganese 2 chloride. Manganese 2 chloride's ions, but is lithium an ion?
No.
No. Sulfuric acid is produced when sulfur trioxide reacts with water. No. Solid zinc? No.
No.
And so we do these So the first step is just to try to recognize metathesis. And so there are actually a lot of problems with the chemical reactions. And so this is from the supplement. This is called reactions 3. Let's take a look at these here next. Phosphorus is burned in air. Metathesis? Phosphorus is burned in air. No. Barium oxide is added to water. Barium oxide is added to water. Metathesis? Well, it depends on how you want to do this. Yes and no for this one. What's the formula for barium oxide? BaO2?
No. Oh, sorry, it's just BAO.
BaO. Okay, so barium oxide, BaO, is added to water. Water is H2O. But metathesis in this form follows this AB plus CD pattern. Now with water, if we call CD HOH, then it's okay. And so what would form here? Okay, barium with the hydroxide, and so we'd get BaOH, and then oxide with hydrogen. Oxide with hydrogen would form H2O. I mean, when we completely, we'll take 2 hydrogens for every oxide. And so it's going to form H2O. Like that. So, does it look like, what could we say is the driving force for this? So this one we'll just save for later because of how we treated this. It's a little bit tricky. So this one we'll save a little bit later after I talk about acid base. There's another way of approaching it. So that's one way you might try to do it. How about this number 3? Sulfur trioxide is bubbled into water. Does it sound like metathesis? No. No, because water, if it's pure water, are there ions in pure water? No. And so typically we don't think of water as being metathesis agent because there aren't ions in there to any degree. And so, number 2 I wouldn't have classified as metathesis. Some people might classify it as metathesis if you treat water like that. And then some reactions do work out. Okay, hydrogen and chlorine are reactive. Metathesis?
No.
Aluminum reacts with bromine.
No.
Calcium carbonate is heated.
Yes.
No, because we're looking for ion combinations. So we only have one ion combination, calcium carbonate. Are there any other potential ion combinations? No. So no. Sodium chlorate is heated.
No.
Barium hydroxide is heated.
No.
No. These are not metathesis. Pure liquid sulfuric acid is strongly heated until it decomposes. No. Propane gas is burned in air.
No.
Acetic acid is completely oxidized.
No.
No. Butane gas is burned in air.
No.
No. So no metathesis so far. Let's keep going here. Calcium is dropped into water. No. Magnesium metal is added to silver nitrate.
No.
Is it magnesium ion or magnesium metal?
It's magnesium metal.
Magnesium metal is the element, so it's not an ion. So we're looking at an element plus 2 ions, the silver ion and the nitrate ion. And so that's not an example of metathesis because it's just Mg solid, which is magnesium metal, and then silver nitrate, which is AgNO3. And so what are the ion combinations that we can do here? Well, this is not an ion, so then no. Aluminum is added to sulfuric acid.
No.
No. Phosphoric acid and excess potassium hydroxide are mixed. Yes. Yeah, that's a metathesis. Phosphoric acid is our AB. What is phosphoric acid? H3PO4. And then sodium hydroxide, or no, potassium hydroxide, KOH. And so now we have hydrogen ions with hydroxide ions. Hydrogen with hydroxide forms water. I'll just write it HOH like that. And then we have potassium ions with phosphate, which is going to be KPO4. K3PO4. Good. And so do we have a driving force here? Well, water is a liquid, and potassium phosphate is soluble. All group 1 salts are soluble. And so is there a driving force for this?
No.
Yes, there is. Actually, what is it?
Stronger acid.
Yeah, so this is our stronger acid, phosphoric. What's our weaker acid? Water. So we do have driving force. So we'll balance it. I'm going to need 3 KOHs and 3 waters to balance it. So that's that. So that was metathesis. 17, aqueous solutions of calcium chloride and ammonium sulfate are mixed. Is that metathesis?
Yes.
Yes. Okay, why don't you try it then? Try number 17. And tell me what you guys get. Try number 17 and